All right, so I was going to do the last problem in the notes, but I kind of wanted to do a homework problem instead, because I think the homework problem is actually a little bit trickier. This is actually one I would have done in class with you guys, and I realized that like we would do this a lot, and I didn't do it at all, but I think I was just trying to get through the material. So I'm going to do number 34. You guys also have to do number 30. I do think 30 is easier than 34, but I'm going to do 34 instead. So I just want us to go through this problem. So a 155-foot antenna is on top of a tall building. From the point on the ground, the angle of elevation at the top of the antenna is 28.5. The angle of elevation at the bottom of the antenna from the same point is 23.5. How tall is the building? Cool. All right. So I'm going to cross this problem off and do my own problem. We'll kind of do my own problem. So it's kind of done the same way, but I kind of like to do, you guys should see a homework problem. It's been a while. All right, so let's draw the picture. All right, so we have a tall building. It's nice and vague, right? There's a 155-foot antenna. Okay. From a point on the ground, the angle of elevation to the top of the antenna. So we'll do a point on the ground. Here's our ground. Point on the ground. The point on the ground, the angle of elevation to the top of the antenna is 28.5. All right. And the angle of elevation from the bottom of the antenna to the same point is going to be 23.5. So this is 28.5. Ooh, this is 23.5. All right, cool. They want us to know what the height of the building is. All right. So this looks fun. All right, we see two triangles here. You should see two triangles here. If you don't, I'm going to show them to you. All right, there's a triangle here, this one right here, and then there's a non-right triangle, this little thin one. So what I'm actually there's three triangles, and there's a big triangle here. So there's actually three triangles. So, all right, we're going to kind of get this together here. So I'm going to call the height of the building H. I'm going to call this hypotenuse L. All right, so I'm actually going to separate out these three triangles. I have two right triangles, and I have a weird non-right triangle. So here we go. So I'm going to draw this big triangle here. So this is going to be 155, that little piece here. And this is going to be H for the height of the building. There's my hypotenuse, it's L. Now, the angle here is actually the angle from the ground to L. So this one is going to be 28.5 degrees. All right, so that's triangle number one. All right, this one's going to be helpful. They're all going to be helpful. So we all need them for like different reasons. All right, I'm going to draw this like little weird looking triangle up top here. Okay. All right, so this is 155. Write this guy in here. This is L. Now the angle in here, this angle in here is the difference between these two angles. So this angle in here is 28.5 minus 23.5, which is just 5 degrees. All right, very exciting. You're probably like, that's not exciting. It's very exciting. So that's our second triangle. And then our third triangle is really this one. It just has the height of the building. It has this side that I don't know. This angle is 23.5. This is H. This is a right triangle. So is this one. I forgot to label it. Now, just watch carefully. This side of this triangle is the same as this side of this triangle. They're all it's kind of the same thing. So what I'm going to do is I'm going to call this side X. All right. So we have L's, we have X's, we have H's, we have all sorts of stuff. All right. The main goal is to find H. So let's see if we can do that. So what I'm going to do is I'm going to first find this angle right in here. I'm going to find what this big angle is. So I'm going to do 180 minus 90 plus 28.5. All right. And that's going to give me 61.5 when you plug it into your calculator. So this is 61.5 degrees. This is 61.5 degrees, which makes this 61.5 degrees. So this is all like very exciting. So now I really don't need this big L. It doesn't really, I mean, we could eventually use it, but we don't really need to. And if you notice, I have nothing else for like this big triangle. So I don't really need to find this L, but what I would really like to find is X. And I would really like to find X because it really does have one part and two triangles in it. So what I'm going to do, why this was important, is because I would need to find this angle so I could find X. I want to find X. L is not really going to be that important. You could find it, but it's not going to be relevant. So what I'm going to do is I'm going to use law of sines to find X. So I'm going to use the combo that I have, 155 and 5. So sine of 5 degrees over 155 is equal to the sine of 61.5 degrees over X. We cross multiply. We get X sine of 5 degrees is equal to 155 sine of 61.5. Divide by the sine of 5. Divide by sine of 5. We get X is equal to about 1563. That is this distance. So that's this distance. That's this distance. Oop, 1563. Give myself a decimal I didn't need to. All right, now if I have X, I can actually find H. So I'll get back to why we drew this triangle in a second. So if we find X, we can find H. Because it's a right triangle, because we have SOHCAHTOA, we have all of this fun stuff, I can use sine. I can say that the sine of 23.5 degrees is equal to H over 1563. I can cross multiply both sides by 1563, and I'm going to get H is equal to 623 feet. And that would be my answer. So this is one way to do it. This is actually the way that I saw how to do it. There is another way to do it with this triangle. So as opposed to using this triangle and this one, we would have used this one and this one. So I can do it that way too. So what we're going to do is we're going to find L instead of this X. So I still need this. I still need to find L. So I'm kind of running out of room here. So I can find L by finding this angle here. So this is 61.5. This is 5 degrees. So that's 66.5. I'm going to show you both ways. 180 minus 66.5. So that angle in there is 113.5. 113.5. So if I find L, once again, we do sine of 61.5. Oh, I'm sorry, I got backwards. My apologies. Sine of 5 over 155 is equal to the sine of 113.5 over L. We can cross multiply here. I didn't do it this way, so I'm going to do this kind of with you guys. So I get 155 sine of 113.5 divided by divided by 155. My apologies. Oh, no, I'm sorry, divided by the sine of 5. Oh, so what happens when I try to do this on the fly? Sine of 5, there we go. All right, so I get L is 1631. All right, now I get L is 1631. It should be bigger than X. That actually makes sense. Like if you're comparing the two answers, it should be bigger than X. Now, I can use sine here now to find H. But the problem is that this whole side is going to be H plus 155. So just something to be aware of when we do this problem. So I'm going to say sine of 28.5 is equal to H plus 155 over 1631. All right. 1631 times the sine of 28.5, 77.8. So that's going to be 77.8 is equal to h plus 155. So 778 minus 155, 623, 623. All right, so we did this problem two different ways. All right, so one way had us finding this side x, and solving, we needed these two triangles here. We needed the small one, and then we needed the small right angle, and then we needed this weird one. And the other way we did it is we used it using the big right triangle, finding L using that weird non-right triangle. Either way, we still got, I wrote 625. My apologies, guys. 623. Ooh, brutal. All right. Either way, we still got the right answer. It doesn't matter which way you choose to do it. It matters which way you decide you want to see it. All right. So you also have number 30. Number 30 is probably a little bit easier than 34. At least I thought so. So if you have any questions on either of those, please let me know.